right, this is the page 4 of continued practice in probabilities, section 10.1 and 10.4. Let's roll 2 dice. Here is a visual representation of the sample space of rolling 2 die as an action or an experiment. Okay, all the different things that can happen. It's 6 by 6. So there are 36 different outcomes in your sample space for rolling the action of rolling 2 die. Okay. The orange is the first possibility of the first die. Okay. If you roll a 1 on the first, die, on the second die, you can roll a 1, a 2, a 3, a 4, a 5, or 6. If you roll a 2, you can also roll a 1, a 2, a 3, and so forth. So you're going to get 36 different outcomes when you roll 2 die. You can roll 1 and then the other, or 2 at once. It's the same. Okay. So what is the probability of rolling a 7? So you don't have to have the visual. It's certainly helpful. You can see that that's a 7. These are all combinations of a 7, and there are 6 of them out of 36 different possibilities. Or you can think to yourself, what would make a 7? Well, if I rolled a 1 first and then a 6, that would make a 7. If I rolled a 6 and a 1, that would make a 7, and so forth. 5 and 2, 2 and 5. Notice the order matters because the orange is the first die and the white is the second. So there are 2 ways to roll a 3 and a 4. Okay. You can roll the 3 first and then the 4, or a 4 first and then the 3, because you have 2 different die. Okay. 1, 2, 3, 4, 5, 6. This should be set notation, but anyway. Let's see, 6 divided by 6 is 1 over 6. If you put that in your calculator, you're going to get a decimal answer of a repeating 6. If Alex wants a 4-digit 4 place value decimal answer, don't forget to round here. Okay, round it to 4 decimal places. So pay attention to how they want it, fractional or decimal. Let's see, the sum of 2 or 12, I changed those numbers. So 2 or 12, let's see, sum of 2. Well, that can only be a 1 and a 1. Sum of 12 can only be a 6 and a 6. So there are only 2 possibilities out of 36. Divided by 2. Yeah, oops. Divided, I was thinking of something else at the same time. So you make sure if you put a fraction down that you're reducing it. Okay. If you're needing a decimal, this is 0.05 repeating. So 4 decimals, 0.0556 on the end. Okay. Maybe they want a percentage. This is what, 16.67%. Maybe they want a percentage rounded to 1 decimal place. So be careful on what type of answer they're asking for. It does matter. You will get dinged on this, so it does matter. Finishing your answer in the proper form is very important in math. You don't want to lose your partial credit on that, so make sure you're paying attention to that. What is the probability of rolling a number greater than 10? So between the two of them, greater than 10, I can look at here. Greater than 10 does not mean equal to 10. And obviously there's not a 10 on the die. So we're summing up to something greater than 10. If you see, these are 10 here. So we're talking these 3. So you could have a 6 and a 5. A 5 and a 6 would make it 11, and a 12 is a 6 and a 6. So that's 3 possibilities out of 36. Reduce 1/12 in the calculator is 0.083 repeating. What if they want a whole percent? That would be 8%, right? Approximately 8%. 8%. Okay. All right. Let's see. Underneath of that is we will study 2 interpretations of probabilities, theoretical and empirical. The theoretical approach requires equally likely outcomes. If the outcomes are not equally likely, we must have used the observation of what happened for empirical probability. So let's look at examples of that. Theoretical probability based on the fixed mathematical possibilities of the only things that could happen. Let E be an event in the sample space, S. N of E be the number of outcomes in E, and N of S be the number of outcomes in S, where the probability of E is the following. So number of outcomes over the number of outcomes. All right, so it might make more sense to see an example of this. Theoretical probability. If you're rolling a 6-sided die, the total possible outcomes are 1 through 6, and each is equally likely in a fair die. Okay, so the probability of rolling a 7 is 0 over 6 or 0, because there's no 7 when you're rolling one die, right? Rolling one die, rolling a 3 is 1 out of 6. So this is kind of what we've been doing above. We're just going to go ahead and call this a theoretical probability, okay? Because it's based on the mathematical probabilities of the only things that could happen. So we just did dice, we did a spinner and coins. These are theoretical probabilities, okay? Rolling a 3, rolling a number less than 5. Okay, we'll do the other kind on the next.